Всем здорово, с вами Рики. Сегодня я с вами поделюсь своим новым Relighting инструментом. С помощью него вы сможете добавить в сцену много реалистичных 3D ламп, которые умеют не только светить, но и отбрасывать тени. Вот две сцены, которые я по фасту собрал, используя эти лампы. Помимо ламп есть даже Ambient Occlusion. Данный Relighting Tool состоит из большого количества плагинов и скрипта. Плагины рисуют 3D лампы, а скрипт автоматизирует процесс добавления этих ламп в сцену. Скрипт и все эти плагины написаны мной с нуля. Скачать их, а также проект с полицейскими машинами вы можете абсолютно бесплатно по ссылке в описании. Создавать данный Relighting Tool было очень непросто, так что если он вам понравится, буду рад донату на бусти. Со вступлением закончили, начинаем туториал. Он будет озвучен на английском языке с помощью голосового помощника. Так большее количество людей сможет посмотреть видео без субтитров. Если вы по какой-то причине не владеете базовым английским, то читайте субтитры.
Hi everyone, I'm voice assistant Herda, and my voice will be used until the end of the tutorial. Let's get started. To make the relighting tool work, you need to record game footage, EXR depth and camera data. The only games I know that can provide these layers are CS2, CSGO, Call of Duty 4 and Black Ops 2. If you're a beginner, I recommend you to start with CSGO. You can find plenty of good tutorials in my playlist. Once you're comfortable with CSGO, you can try following CS2 tutorials. My CSGO and CS2 configs are almost identical, so it shouldn't be difficult to understand. Let's record a cinematic. As I said earlier, you need to record a game layer, EXR depth and camera. Once recording is finished, import the layers using my HLE After Effects Tools script that I covered in this tutorial. Done. Let's adjust the project settings. It's super important. First, set video rendering to Mercury GPU acceleration, CUDA. If you don't have this option, then you probably don't have an NVIDIA GPU. Without NVIDIA, you won't be able to use my relighting tool. Next, set project bit to 32, so you can change brightness of the lights without any issues. And finally, set expressions engine to JavaScript to make all expressions work. Let's install the relighting tool. Go to Releases and download relighting.zip. Move relighting folder and script to Script UI Panels folder. And Ricky folder that contains plugins to MediaCore. Once installed, reopen After Effects, go to Window and launch the relighting script. How to use the script? It's simple. Select a depth layer and press the plus button. It will add a controller, which allows you to quickly extract coordinates. To make it work correctly, you need to adjust the depth settings. The first parameter is depth, black is near. If the depth looks black in the near, check this box. My depth looks white, so I'm leaving it unchecked. The second parameter is depth far, which represents the distance to the farthest point in the depth map. This value should match the value specified in the extractor effect. If you're using my CS2 or CSGO configs, the value for the EXR depth will always be 25,000. Great, now you can project a 3D solid to any pixel using this cursor. To spawn an object at the selected point, select the depth projection layer. Choose the desired object, for example a point light, and click Project. You can spawn as many objects as you want. As you can see, every object matches the transform of the projected solid. It's very handy. By the way, if you're wondering how 3D plus 2D null can be used, check my first relighting tutorial. Once you've finished spawning the objects, I recommend hiding the projected solid, as it heavily impacts performance. Alright, now that we've covered the basics, Let's spawn a 3D light. We'll start with a point simple. Select the point where you want to place the light, and click Project. After that, you need to wait about 10 seconds, because 3D lights have a complex structure. If it takes much longer than that, and still nothing happens, then your After Effects is probably going to crash. Don't panic. Every time you click Project, the script automatically saves your project, so your progress won't be lost. If nothing happens for too long, just reopen After Effects and try again. Fortunately, in my case, After Effects didn't crash. You can change the light's position by moving the null object. On the same null, you can adjust the light's parameters. Radius controls the size of the light. Falloff controls how quickly the light fades. Intensity controls brightness. Saturation controls colorfulness. Color near is the main color of the light. Color far is the color light fades in. Color far toggle checkbox enables or disables the far color. Color falloff controls the transition between near and far colors. If you want to create another point light, simply duplicate the null using Ctrl+D. Then, choose a point simple composition and select the new duplicated null. That's it. You can configure the new light in exactly the same way. To hide one of the point lights, simply disable the null object. If you want to adjust a specific parameter for all lights at the same time, go to Point Simple, Global Light Settings, and tweak the desired parameter. Now that you understand how to use it, let me explain how this whole setup is built. When you project a point symbol, the script duplicates the depth layer and applies point simple effect to it. This effect reads data from the depth map, camera, and selected nulls, then generates a light on a black background. Additionally, the unmult effect is applied. It makes black areas transparent. Next, the script sets the blending mode to overlay. It makes the light blend beautifully onto the scene. Beneath the light layer, there's also an adjustment layer with the clamp effect. Currently, the pixel values exceed the 0-1 range. Applying the clamp effect will limit them to 0-1. Let me show you why it's needed. I made 2 separate point simple compositions. If I increase the brightness of the bottom light, you will get artifacts. It happens because the overlay blending mode doesn't work properly with pixel values outside the 0-1 range. But if you place the clamp underneath the layer with the overlay blending mode, everything will be fixed, as it clamps the pixel values to the 0-1 range. By the way, the overlay blending mode is not the only one that has issues with pixel values outside 0-1 range. Different types of blurs, glows, and other effects have the same issue. That's where the clamp effect comes in handy. Let's move on to the point advanced light. This light consists of 3 types: ambient, diffuse, and specular. By default, only ambient is enabled. Ambient works absolutely the same as point simple light. Let's compare ambient to diffuse by matching the parameters. Here's before and here's after. See the difference? Diffuse lighting looks much better. Specular lighting represents reflections of the light source on glossy materials. The setup for this light is slightly different. When you project a point advanced light, the script creates 2 duplicates of the depth projection layer. To the first duplicate, it applies the point advanced effect, which reads data from the depth map, camera, nulls, and normal map, then draws a 3D light. What is a normal map, you might ask? Great question. A normal map is a layer that shows the direction each pixel is facing. This information is essential for diffuse and specular lighting to work. The normal map is generated by applying the depth to normal effect to the second duplicate of the depth projection layer. The only parameters you need to focus on are in the smooth category. If you uncheck the smooth checkbox, the light's edges will become sharp and unnatural, so it's best to keep it enabled. For even smoother edges, lower the threshold slider. There's also the depth weight parameter, which removes the unwanted blur around the edges. That's not all. The point advanced light can also cast shadows. I prepared a better scene to showcase them. Here's a single light. Look what happens when I enable shadows. Oh, looks beautiful. However, shadows come with two drawbacks. First, their screen space. For example, if I move the camera so the fence is not visible anymore, the shadows it was casting will instantly disappear. The second downside is that they're extremely performance intensive. Let's take a closer look at the shadows parameters. Sample step: the lower the value, the more accurate shadows are. Improved sample radius: the higher the value, the more accurate shadows are. When this parameter is set to 0, you'll see the light passes through the walls. But if you increase it, the issue is fixed. Max length limits maximum shadow distance to optimize performance. Threshold controls density of the shadow. For optimal results, keep threshold start at 1 and threshold end between 2 and 5. Softness radius blurs the shadows. Softness samples determine the quality of the blur. Keep in mind that soft shadows are extremely performance intensive. Setting softness samples to 16 means the shadow will be calculated 16 times at slightly different positions. Intensity parameter controls the shadow opacity. If you set the shadow color to anything other than pure black, increasing intensity will actually make the shadows brighter. Shadows are clipped by default for optimization. To disable clipping, uncheck Clip to Light. Finally, let's enable all types of lighting, so I can show you another useful parameter: render mode. It allows you to preview each type of lighting and shadows separately. By default, the shadows affect all 3 types of lighting, but you can change the behavior by changing these checkboxes. Tired of dragging lights pixel by pixel? Here's a pro trick. Duplicate the light. Link it to the projected solid by holding Shift. Slightly move the light so it's visible. Boom, now you can move it using the cursor. Once you've placed the light exactly where you want it, simply unlink it. Let's move on to the spot simple light. If you want to place it on the floor, I recommend disabling auto orientation. You'll get a setup similar to the point light, but this time, you have 2 nulls. The first null controls the position of the light source. The second null controls the direction the spotlight is pointing. Let's look at the parameters. Look at is the layer the spotlight will point toward. Right now, it's set to the second null. If you find this inconvenient, you can disable this feature and rotate the spotlight manually. I'll leave it enabled for now. The next checkbox means the spotlight's range equals the distance between the 2 nulls. If you uncheck it, you can set the light range manually. Fall off controls how the light fades along the z-axis. Feather softens the edges of the light. Curvature controls how much the light beam bends. Angle controls the width of the light cone. If you uncheck Uniform Angle, you can adjust the angle independently on the X and Y axes. Intensity, saturation, color work the same way as with the point light. The final feature, IES. This creates an interesting fade pattern along the edges of the light. If you choose Custom, you can design the fade however you like. These 6 parameters generate a black and white gradient, which is applied to the light as a mask. To add another spotlight, duplicate both nulls. Assign the new look at null. And in the Spot Simple effect, select the null that contains all the spotlight parameters. Next up, Spot Advanced. It has 2 more lighting types and shadows. To make the diffuse lighting fully visible, lift the light source above the ground. Let's take a look at Rect Simple. Rect Start, where the light begins. Rect End, where the light ends. You can resize the light by scaling the nulls. Here's a visual representation of how the light works. If you want to make the light placement easier, you can link the Rect End to the Rect Start. Light parameters are quite simple. Fall off, how fast the light fades as it goes forward. Feather, softness around the edges of the light. Feather uniform, if unchecked, you can set softness for each side separately. Currently, feather is measured as a percentage from 0 to 1. If you uncheck feather normalize, it will be measured in pixels instead. To add another Rect Light, duplicate both nulls, then select them both in the Rect Simple effect. Rect Advanced works the same way, but has a better lighting and can cast shadows. Moving on to the directional light, it mimics sunlight. You can control the light's direction using 2 nulls, directional start and directional end. This light uses an improved lighting model and supports shadow casting. For easier placement, you can link the directional end to the directional start. For the final light, I prepared a new scene. As you can see, even though there's a strong light in front of the player, his back remains completely black, which looks unrealistic. To fix this, let's add a rim light. You can control the light's direction using the rim light and rim look at nulls. Since the light should face toward the camera, I'm moving the rim look at null closer to the camera. After fine-tuning the parameters, we achieved a nice edge glow. We only want this glow to appear on the player, so let's mask it. In CSGO, you can record a separate layer with players only. In CS2, you need to manually mask players using a Rect Simple light. Fortunately, I'm working in CSGO, so I can simply apply the Set Matte effect and select the player's only layer. It works, but there's an unwanted white outline around the edges. To fix that, we need to slightly shrink the mask. This can be done using the simple choker effect. Perfect. The last step is to soften those harsh edges. You can do this by lowering the threshold value in the normal map settings. Here's before, and here's after. A clear improvement. You thought that was it? Nope. There's also an ambient occlusion effect. It generates soft edge shadows that add extra depth to the scene. It only has a few parameters. Intensity controls how dark the shadows appear. Threshold determines which angles can cast shadows. The higher the value, the sharper the angle between pixels needs to be to generate a shadow. X, Y, and Z radius control the sampling area. The higher the radius, the farther the shadows will spread. Samples adjusts the quality of the shadows. Higher values equals cleaner results, but heavier render cost. Here's the before and after. As you can see, the scene now has way more depth and realism. Congratulations! We have covered the main relighting tool functionality. Actually, it's very easy to use. You just need some time to get used to it. As a bonus, I will show you how to use this tool in Call of Duty 4. It's slightly different rather than Counter-Strike. First, you need to record the required layers. You can watch this tutorial by Polito. Make sure to use the Legacy MVM launcher and these commands. Next, you need to convert the layers to a different AVI format, because this one is buggy. To do this, you can use my converter. Please read installation and usage before using this batch script. Otherwise, it will not work. Once converted, you can delete the original cinematic. Now, you need to install the MVMTools script. It allows you to import camera data and convert depth. Paste it to the script UI panels. Let's import the layers. Create a folder. Import the layers into that folder. Create a composition by dragging the folder onto the new composition icon. Select single composition. Good. Let's adjust the project settings. It's super important. Set video rendering to Mercury GPU acceleration, CUDA. Project bit to 32. And expressions engine to JavaScript. Next, open the MVMTools script. Convert the depths. Import the camera. Nulls can be deleted. Select the camera, press U. Select all keyframes and toggle hold keyframes. This way your 3D tracking will stay accurate even after using time remapping. Let's adjust the normal map. First, rename it to the normal pass 1. Then apply the normal remap effect and paste these settings. This effect is very important because the coordinate axes in the game and After Effects are different. Keep going. Open the Relighting script, select the depth map and make a setup by pressing the plus button. Go to the depth settings and set the depth far to 4080. Congrats, the hardest work is finally done. Now you can project any 3D light. Unfortunately, auto orientation and shadows are not going to work because Call of Duty's depth map is not good enough. The tutorial has ended. If you have any questions or found a bug, feel free to join my Discord server. If you enjoyed the Relighting tool and would like to support my work, donations via my Boosty page are always appreciated. Thanks for your time, happy creating, and see you next time.